G'day Year 7s, and here is our second video for Chapter 9, looking here at exercise 9b, which is quite simply looking at triangles. The word triangle, obviously triangle, if we break it up, so meaning that there are three angles within that shape. Now triangles are they're actually important, as it says here. Triangle is an important building block in mathematical geometry, and also very much used in the real world in building and construction. As you can see here, the bridge with a variety of triangles being used, there and there, all the way through. And using triangles in this way and interlocking them up actually gives this bridge a great deal of strength, which is obviously needed for a bridge. You don't want one that's not very strong, is going to fall down. Anyway, so yeah, important concept, geometry and triangles in particular, particularly if you're getting into, think you may be getting into the building industry or something like that. Very, very important. All right. Triangles can be named using the vertex labels. So a few notes you need to take here into your book. So as we said in the previous video, each of the vertices are labelled with capital letters, so in this case A, B and C, in an anti-clockwise direction. Could also be done in a clockwise direction, doesn't really matter. Now, you can classify triangles in a couple of different ways. One is by their side lengths. Okay, so we've got a scalene, so you need to write all these guys in your books, please. So make sure you've got your books there and you are pausing this if needed and writing these down. So scalene triangles have three different side lengths. All right, so all the side lengths of a scalene triangle are different. And the other thing that creates is that it gives it three different angles. The angles are all different in each of the vertices there. Okay, next one you've got is an isosceles. An isosceles triangle has two equal sides, as you can see here and marked with these dashes. Okay, so two equal sides, and the other thing that also creates is two angles that are equal down in the bottom. All right, and each of these arms are going to be opposite each of the equal angles that are at the bottom. Okay, so an isosceles, two equal sides, two equal angles. And the last one we have is an equilateral. So equal. Okay, that one's an easy one to pick because equilateral, equal, meaning everything is equal. So all the side lengths are equal and all the angles are equal. And they will always be 60 degrees because how many degrees in a triangle? I'll say that again. What do all the angles in a triangle add up to? Okay, hopefully you said, Mr. O'Donnell, eventually we knew what we were talking about, 180 degrees. So if all the angles are equal in an equilateral triangle, they've always got to be 60 degrees. They can't be anything else. All right, otherwise they won't add up to 180. All right, so they can be classified, as we've just seen, by side lengths, and that also creates the different types of angles within each one. All right, triangles can also be classified by the size of their interior angles. Okay, so if all angles are acute, so what's an acute angle? Okay, hopefully you're saying it is less than 90 degrees, so an acute angle is less than 90 degrees. All right, less than 90 degrees. Hang on, forget that one. Won't do it that way. Won't be able to fit it in. All right, so acute angles, so all less than 90 degrees, so that is an acute triangle. You've got a right triangle, which means there is one right angle within that triangle. Okay, so right angle triangle also, and then you've also got an obtuse triangle, which means there is one obtuse angle within that triangle, and obtuse angles are between 90 and 180 degrees. Okay, is an obtuse angle. Okay, so they're the different styles you've got. So scalene, isosceles, equilateral. Make sure you understand each of those. Okay, and different types in terms of interior angles. So interior meaning inside, so all the inside angles. Okay, so you've got an acute triangle, a right angle triangle, a right triangle, and an obtuse triangle. Okay, with each one giving you different types of interior angles. The parts of an isosceles triangle are named as shown opposite here. So you've got your apex, you've got your legs here and here. Okay, you've got your base, and then you've got your angles, or base angles in there. Okay, all right, let's have a look. Classify these triangles. Alright, so A, we've got to classify by their side lengths, so is it either scalene, isosceles or equilateral. So what I want you to do is actually pause for a minute and pause it, and I want you to actually do these problems and we'll come back and have a look at them. Alright, so pause it now, off you go. Okay, welcome back. Again, hopefully you have paused it. Otherwise I sound a bit silly when I do that. Alright, so we have got by the side lengths, scalene, isosceles or equilateral. So here it is telling us that these two side lengths here are exactly the same. So if we have a look at our side lengths, two side lengths are the same here. So we're looking at an isosceles. So this one is A, and isosceles, and two, their angles. So these angles in here, is it an acute, right or obtuse? Well, they're all under 90 degrees, so it is an acute triangle. Okay, there's that one done. Part B, this triangle over here. So we've got all the side lengths here, as you can see in the picture, are all different lengths. So all different side lengths. So all three different sides means we've got a scalene triangle. Okay, so our triangle there is a scalene. And their angles, acute, right or obtuse. Okay, well these guys are going to be acute, but this one is looking to me beyond 90 degrees. Alright, so if I use that arm, 90 degrees is going to come down here, so it's above 90 degrees. So it has got to be an obtuse triangle. And let's see if we got these right. Don't want that one. Triangles. Where are we? Okay, yep, isosceles and acute. We had that one, isosceles and acute. And part B, scalene and, go away, scalene and obtuse. Scalene and obtuse. Alright, so we got both those guys right. Oh, we've done well. Alright, constructing triangles. Alright, so drawing triangles are also part of this. So I'm going to have to use a bit of technology up on my little team board program here. So we need to draw a triangle ABC. Alright, so if I over here, it's going to look like A, B and C. Okay, my AB length is 5 centimeters. I've got an angle here of ABC of 30 degrees. So remember, this middle part tells me what the angle is. So this angle at B, which is going to be in there, has to be 30 degrees. And angle BAC, so BAC, so this angle has got to be 45, which is in there. So it's that middle letter tells you where, which apex, don't need to see that one, which apex, which vertice that angle is going to be in. Okay, so to do that we are going to need a ruler to begin with. Okay, so I'm just going to put the ruler down here. So my length from A to B has got to be 5 centimeters. So hopefully this works. So from here, where are we? Yep. Alright, so from here, 1, 2, 3, 4, 5. So you get your ruler out and you're trying to get that as straight as I can. Oh, that didn't work very well. Let's have another go at that one. This might be a little bit fiddly, but we'll get there. So it's got to be 5 centimeters. There. Oh, lovely. Okay, so now our angle at ABC, so ABC in here, has got to be 30 degrees. Alright, so I need my protractor. So you're going to need rulers and protractors here. Just going to actually, I'll click that off, get rid of it. So my angle at ABC, so I've got to put my protractor at that end of the line because that's going to be, and what I'll do, I'll mark that as, geez, sometimes I tell you, I want the pen. So that's going to be A, thank you. That's going to be B there. Now I need to go back to my line. So I'm going to bring this over here. So my angle at B has to be, what was it? 30 degrees. Alright, so I'm reading this way. Okay, so from 0 here to 30 there. So I'm going to, yep, got that one. So from here, I need to make sure I draw my line at 30 degrees. Okay, so why didn't you work, little brat? Let's try again. dear. Sometimes technology. Okay. Serial. Let's try again. Dear. Dear, oh dear. Hang on, what have we done? So, no, I don't want that one. I want that one. Okay, let's try again. Now it should be good. Okay, from there to there, so that's 30. So I'm measuring from here, from 0 up to 30. So I'm looking at the outside numbers. So 30 degrees there. And my angle at BAC, so BAC, so over here, so A has got to be 45 degrees. So I'm going to put that there. Make sure it's the center of my protractor is right at the end of that line. Draw my don't do that to me again. Alright, let's try again. And that's got to be 45. So I'm reading from the inside numbers now. Okay, so going from this side, 0 up to 30, 45 is here. And you didn't want to draw. Let's try that again. 45 degrees. Okay, alright, and that is our triangle. I'm going to click that off. I'm going to get my eraser. I want that. I'm going to rub that part of the line out. I'm going to rub that part of the line out. And we now have a triangle with a AB length. I want that, thanks. And that, thanks. And that's C up there. So my AB length is 5 centimeters. In there, my angle ABC here, so that angle is 30 degrees, and my angle BAC, so BAC in here, that angle is 45 degrees. Okay, and so that's simply how you construct it. So you need a ruler and you need a protractor. All right. That is all we need to do. So hopefully that made sense to you. So yes, we're going to be doing some more constructions, which I know some of you really love. Some of you really don't. But anyway, we'll learn how to do these and do these well. All right, hopefully that makes sense. A little bit longer this video, a little bit of mucking around, but we got there. All right, thanks guys. That sets you up for exercise 9B. Good luck. Bye-bye.